if you Google, okay, if you Google his name, okay, he actually quite prominent in this research area, in especially in construction safety. Then you will see how's his work in I mean in this industry. All right. So thank you again, Prof. Mike. Good to see you, and of course, I will see you again in the future, frequently. I don't know, either online or physical. All right. So I think I'll pass this to Dr. Elma. All right. I think everyone's already. I think we can start, Dr. Elma. All right. Thank you, Prof. Mike, again. Good to see you.
All right. I think the student will join us. Okay. Time by time. Okay. So I think we start, Prof. Can? All right.
Great.
Okay.
Yeah. Well,
All right.
thank you.
Hi. Okay. Good evening. And
Yes,
welcome.
but before
Yes.
we start, can we take a photo first? Because
Yeah.
I'm not sure is it I'm in line later
All
on.
right. All right. Okay. Sure.
But in my phone, I didn't know how to see everyone in the screen or not.
Everyone can.
I'll stop
Yeah.
the sharing.
It's
So
okay. So
Yeah.
we have
Please, some whoever with the camera, please turn on the camera, class. Um,
okay.
I don't area here, Prof. Mike. Do you know White Plains? Is a northern part of New York.
yeah, I've heard of it.
Okay. So I live here with my friends. I mean, in my friend's place.
Excellent. It's great to see everybody.
Okay.
Okay. All right.
Okay.
Count 3, 2, 1. Smile.
One more.
I think wait, I need to paste first in the WhatsApp
Oh, okay.
because I take a snapshot.
Oh, okay.
All right.
Oh, you don't use MacBook, that's why.
Yeah.
Okay. All right.
Okay, one more. Wait, wait.
Okay.
One more. Okay, 1, 2, 3.
Smile. All right. Okay.
Perfect.
Thank you.
Right. Okay, Lina.
All right. Well, it's great to see everybody. It's great to be here. I think I did this a similar lecture last year for the class. It's great to be back. And it was great to see Lena again after 10 years. And I have a picture of Lena and I to share with everybody at the end of this presentation.
Wow, that's great. Thank you.
So you'll see you'll see what her and I were up to last week. But and just it's the morning here on the East Coast of the U.S. and I'm drinking my coffee, and so just feel free to ask questions at any time, and we'll try to make this as interactive as possible.
Yes.
So we'll talk a little bit about accident causality. What causes accidents and incidents? We'll talk a little bit about that. We'll talk a little bit about a project that I did. Oh gosh, a long time ago. Probably when I met Lena, first time I was doing this project, maybe 10 or 12, even I think even more, probably 12 or 13 years ago. It's a little bit of an old project, but it's a good project to share. And so yeah. So where am I right now? So I think folks might be familiar with Florida, and folks might be familiar with Washington D.C., and I'm kind of right in the middle of Washington D.C. and down in Florida to the south. Probably a little bit more towards Washington, though. I'm about 4 hours by car south of Washington D.C. On the East Coast in a state called North Carolina. So that's where I'm at today, talking with you. And so let's see if I can move some of this stuff. There we go. So yeah, right. So the big question is, so some of the big questions, right? does the past predict the future when we talk about accidents, right? So as safety and health professionals, we want to anticipate what might happen, and we want to take measures and take actions to prevent those things. So do accidents and incidents, do they predict what might happen in the future? It's a really interesting question. It's something that gets debated quite a bit. And you know, the next question is can we truly learn from accident investigation? Can we truly learn to predict what might happen in the future? And certainly another question is, are investigators biased? Wow, are we biased as humans? Well, I think we might know the answer to that question. And so, wow, how can we remove that bias as investigators? That's a difficult one, I think, right? So we view the world differently, don't we? We people come from all different views and backgrounds, and so here, right, we can look at the same thing, the same physical item, but two people view it very, very differently, right? One views this as a 6, the other views it as a 9, but it's the same physical object. And it's the same when we look at accidents and incidents and we retrospectively go back in time and try to figure out what happened. How can we prevent it in the future, right? So we all have those particular biases, right? So what causes accidents, right? Was maybe there was a comment or a question? No. So maybe you've heard of this little phrase, Wilfy whiff. Wilfy whiff. What you look for is what you find. Well, that kind of goes to our inherent biases as people, right? So you know, we'll find that there's kind of two different views of accidents that happen. What you find, and there's whiffy whiff, whiffy whiff, wilfy whiff, and whiffy whiff. What you find is what you fix. Okay, so what you find is what you fix. Well, how is that going to work? Well, let's just take a look here and see. Right. So there's two approaches, right? There's two approaches and I call them at the extremes. The person approach, right? So we can focus on people and they make errors. We make errors all the time, right? We're forgetful. We don't pay attention all the time, right? We just do things sometimes. We are human. We are fallible. It's part of being human. And then there's the system approach that says, well, we can design everything perfectly and we can make the system perfect. And if we concentrate on these systems, these conditions, the design, the engineering, everything will be just perfect and fine. Well, that doesn't quite work out either all the time. And so I believe the truth is in the middle. I believe the truth is in the middle in most life situations. I think accident causation, the approaches, it also lies in the middle. I think that we need to take a sensible balance of the person approach and of the systems approach. And I think that's where safety professionals come in and your experiences and to help organizations take that balance and to find that balance of holding people accountable, but also realizing that, you know, you've heard of probably the ABC approach, right? Where behavior's in the middle, there's antecedents, behavior, and consequence, right? We can fix and try to understand some of the antecedents that cause poor behavior. So finding that balance, that sensible approach, that's where I think a good safety professional you know, your judgment comes into play. Your knowledge of particular case studies come into play and try to apply them. So we'll try to give you a little case study here today and some examples of that balance, uh, of that balance approach, right? Because I think organizations really have hindsight bias, and perhaps you've studied hindsight bias. I think this is a really interesting area to perhaps take a look at, being able to look back, right? And an investigator, we can always look back after the accident and say, well, why did they do that? They being the people in the accident, or the supervisor, or the designer of the work, right? We can always look back and say, well, why did they do that, right? And so Sidney Decker has written a lot about hindsight bias. I would encourage you to perhaps take a look at some of his work um, as well. When we think about hindsight bias and trying to remove hindsight bias and trying to think about how can we become better investigators, right? And so, well, we say, you probably heard this term. I'm sure you've heard this term, right? We want to find the root cause, right? Well, I'm not sure I really like the term root cause very much. I like to think of it as different types of causes, perhaps multiple. But what kind of root? What kind of root, right? There's two basic types of root. When we look at plant biology, if we really go back to plants, and we think about the basis of what is a root, what kind of a root? Well, we could have a fibrous root, like on the left here is a fibrous root. Many roots with similar sizes. In contrast, the tap root, the carrot, is an example of a tap root, a main root, which a couple of smaller branches branching off. And so actually, when people talk about a root cause, they're really talking about the tap root. And they think, oh, there's one particular cause. But I think, and I'd like to suggest to the group, we need to think about a fibrous root when we think about root causes and fibrous roots, plural, and all of these kind of systems that really influence accidents. So we can have a root cause as long as it's a fibrous root. So we should take that approach as well too. And actually, here in the U.S., we actually there's a consulting company called Taproot Safety, and I think, oh, what a terrible name! What a terrible name for a consulting company. We should be a fibrous root, so with many roots, and really looking at all different types of influences. So the problem that we'll share with you today through a little case study, we have so the Department of Transportation, each state has its own Department of Transportation that takes care of the roads in the state, and they're responsible for building roads and repairing roads and maintaining roads. And so we do some work, we do some research with them, and try to help them understand their safety and health system of their particular workforce and contractors. And so, their problem was, well, gosh, we come back with all these accidents that happen across the state of North Carolina, which is a pretty big state, the seventh largest state in the U.S. They came back and they say, well, all we're doing is blaming people, and we're not really doing thorough investigations. We're just simply kind of blaming our people. And so we want to do better investigations. So what are our problems, right? So we were tasked with helping them with that. And I'll give you these slides. I'll send your profs these slides and so you can have them. So and I'll refer to a couple of papers that we wrote around this particular accident investigation model as well. And I'll be happy to share those with you as well. So, but this is a construction and accident causality model that was developed in the UK out of Loughborough University. A good colleague of mine, Alistair Gibb, I believe Lena met Alistair as well in Ireland, in Northern Ireland, 10 years ago. And so I like this particular model. And so it kind of starts with the accident in the middle and you work your way back, and we'll talk a little bit about what goes into this particular model as well. And the papers as well go into a lot more detail. But it starts with the accident in the middle, and it says, well, there's all these immediate factors. And of course, there's people, right? There's worker factors, there's the work team, and you can trace things. And so the arrows point in towards the accident. But in an accident investigation, we actually work our way back. We work our way back through this model. So, usually we find that people have some influence on the accident. So we work our way back through what was the communication like? What are their capabilities? What are their behaviors? What are their actions, right? We can usually find some things, but we also look at equipment, materials, workplace, and we try to work our way back through those particular factors as well too. And we go through, the model calls those shaping factors, and then there's things that influence all these worker, site, and material factors, these shaping factors, right? So it's like site constraints, attitudes, motivations of folks, supervision, right? So we can kind of use these words to key us and to have us think differently about what really caused this particular accident. And that's how we use this particular model. And we can also go back to what they call in the model originating influences, which are a little bit harder to get at. Things like the client requirements. Wow, it's hard to get at that, right? Permanent works design, how the project was managed, safety culture. What the heck does that mean, right? You've probably talked about safety culture. We actually tried to define safety culture. Um, and so we put an operational definition to all of these particular words that were in this particular model. And so the model is linear. It's a linear accident causation model, which can be critiqued and say, well, linear is probably not a good way of thinking, but that's okay. As long as I think you're getting within the system of things, I think you're okay. But it's kind of like, well, it kind of goes along this a particular trajectory. And maybe you've heard of James Reason. Maybe you've heard of James Reason. He had what he calls a Swiss cheese model of accident causation, where this this model, the Loughborough model that we're showing here, is really based on James Reason's thinking that when these immediate circumstances, shaping factors, originating influences, when they kind of line up, there's this trajectory of an accident opportunity, and these holes are in the Swiss cheese. And when they line up, there's the potential for an accident. So we're kind of looking at it from, again, the accident going back in time. But Swiss cheese, right? Has everyone heard of the Swiss cheese model? Is that familiar to some folks? I don't know, maybe um, maybe if you just kind of thumbs up or raise your hand to say yes or something. Do people know about the Swiss cheese model? Maybe not. Or maybe everyone's tired. It's 8:30 in the evening, isn't it? So everyone's tired, I understand. Well, the Swiss cheese model, I like Swiss cheese. I like to make a sandwich with Swiss cheese sometimes. And I was thinking about Swiss cheese one day that I was making a sandwich, and I was thinking about, wow, that's a big hole in the Swiss cheese. And I was thinking, well, I I think I got ripped off, maybe. Maybe there's where's my cheese? And but I also was thinking about accidents, and I was thinking about the different sizes of holes in the Swiss cheese, and I was thinking about James Reason, and I was thinking, well, geez, there's different types of Swiss cheese. There's different holes, right? And so we have these different types of holes in the Swiss cheese, and these are all gaps in our defenses, is what James Reason would say. And wow, there's even little dimples in this piece of Swiss cheese, and these little dimples are maybe these are the weaknesses that we have in our system, in our layers of defense. And so, our goal is to try to make these holes smaller in workplace safety and health by preventative actions, and so the accident trajectory does not does not happen. So, but again, very very linear model. And so, right, so we can kind of think about this linear model: A equals B. If we do A, then B will happen. And this maybe sounds good in the office, but when we get out in the real world, right, the real world, the manufacturing site, the construction site, it ends up being pretty complex and pretty messy. And so it's not this really nice linear fashion about how things happen. So certainly that's a limitation to this accident causality model that I present to you here. It most certainly is. But for the purposes of this presentation, we'll try to focus just on the accident causation model. But we should realize that there's other ways to look at accidents. There's other ways to think about things that take into account complexity. Um, in some other classes that I teach and some other work that I do, we use FRAM. Maybe you've heard of FRAM, the Functional Resonance Analysis Model, developed by Eric Holnagel. Um, Perhaps you've read some work by Eric Holnagel. I really like his work. I encourage you to check that out. But FRAM, this is just an example of a FRAM model that shows interactions of different types of activities. Right, we can have mind mapping where we show different types of relationships. So there's all different types of ways that we can look at, and different types of mind maps to look at different types of the way that accidents and incidents might occur. And so I'm going to give you these slides. The next couple slides are very wordy. I don't like wordy slides, but they help you kind of use and think through. Uh, so it was developed by Alistair Gibb and Roger Haslam at Loughborough University. So I apologize. It's I go back and forth from the Gibb Haslam model to the Loughborough accident causation model, so that it's the same thing. These are just the authors' names. Um, so as we go through this particular model and try to work our way back through the different uh, factors, influences, and circumstances, the layers, we try to ask questions. Um, and so we try to look at all the relevant causes. So we treat the phrases in the model as questions. So when we see, if worker actions and behaviors are identified, then we would ask, right? We would go back to those particular shaping factors associated with that work team, and we'd say, well, did the workers' attitudes influence the behaviors? Did the supervision contribute to the actions and behaviors? Did the knowledge contribute? So we treat everything like a question, and we try to understand if there's some possibility to learn something about what these particular shaping factors going back to the model might reveal. And so when we have yeses, we keep tracing them back. We try to go back into those influences, and so on and so forth. And so, and we've developed all kinds of, and I can share these with you as well too. We've developed all kinds of worksheets to help people go through and look at these things. And so we've developed, so there's 22 phrases that turn to the questions, and we developed operational definitions of these. The papers give you some examples um, of those operational definitions. And so one example that I'll share with you today with the Department of Transportation, there was a Department of Transportation employee. They were using a planting auger. And so this auger is used to dig holes, and they were putting signposts in. So we call trees, let's see here, we call trees reinforced stationary is what the term that they were used. But they were little trees on the side of the road, on the side of the highway that were being planted. And so the DOT wanted these, they wanted more trees along the highway. And so they were planting trees. And so certainly, in, lawnmowers, they have these big lawnmowers that go through and, and mow the grass. And so, people aren't really paying too much attention. They're just trying to get the most miles mowed every day. So they needed to plant these signs up along where the trees were planted, so the lawnmowers would stay away and not run over and 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 destroy these small trees that were being planted. So this person was using a planting auger, and every 100 feet, they were digging these holes and putting up these signs. They were putting little markers like this. Um, Here's an example of where we they didn't want this stuff mowed, but here's an example, right, where they don't want some of these flowers mowed. So they were putting up these small signs, and so they were digging a hole to plant these particular signs. This might be an example of an auger that they were using to kind of dig these holes and put these signs in. So this kind of gives you a little bit of a pictorial. And so, of course, right, boy, whenever an accident happens, it was the last hole for the day. It was the end of the day. Oh, if only they would have stopped at the previous hole, right? The accident wouldn't have happened, right? But it was the last hole of the day. They were leaning on the auger, right? So you can kind of see here how they're trying, this person might be trying to dig a hole that might be difficult. They're kind of leaning into it. And so they were leaning into it. It was hard clay, and the auger kind of pulled back, and it hit the employee in the face. It hit the employee in the face, and it made a really big cut along their jaw and along their face. And so here's an example of the actual auger and what the employee was doing. And one of the things that you'll notice that we noticed was that, well, these signposts were really small. And so if you go back to this kind of a picture here, the post was actually even smaller than what you see here. And so it was only maybe 2 or 3 inches, and really, really thin, a really thin signpost. It was just something to notify the mowers. It wasn't very, very big or wasn't very stable. It was a very small sign. And a small signpost. So the one thing that we talked about was that, well, did we need this big auger to really do this, right? So the auger they were using was it was over 10 inches in diameter. And so, we questioned, well, why were you using this big auger? Didn't you have smaller blades here? Didn't you have smaller blades to kind of dig a smaller hole, and it would have been a whole lot easier? The answer was yes. They just didn't. There are those types of blades, smaller blades available, but they didn't order them, and they just thought, well, we'll just take the big one and we'll just fill it back in. So it wasn't very productive. They probably could have got more holes dug, quite frankly. With a smaller blade, they would have went a whole lot quicker than that. And so what the DOT said was, well, we're just going to ban augers. We're not going to use these automatic augers. So we thought, well, that doesn't sound quite right. If you had the right tools, I mean, there's nothing particularly unsafe about augers, these automatic augers. But they said, well, that was our solution, and now nobody uses these powered augers. Well, here's what they use now. They use these small, and so you can kind of they use these manual hole diggers where they have to manually kind of reach up and pull it down into the ground to try to make a hole. And boy, that you can imagine that's probably tiring. And if you've studied ergonomics and human factors, you might say, well, that maybe maybe that's not the best thing for someone to be doing all day, 5 days a week for 8 or 10 hours a day. And you'd probably be right about that. And so it could cause some shoulder, some back pain for sure. You're reaching up and you're pulling this thing down into the hard ground, into clay type soil, perhaps. And so we question that. Well, is this really the safest solution is to ban these augers? Why don't you have the right equipment and tools to do the job? And so, so in their incident investigation, when they investigated this, they said, well, the employees just they don't do stuff correctly, so we're going to ban those augers. And so that was their solution, and so we kind of questioned that. So that's just one example, I think, of kind of how we traced back and we said, well, if you have the right equipment, this was an equipment issue. Um, the right equipment, there were local hazards, there were things about the site that we found during our investigation. And so when we were using this causation model, we found an average of 6 factors and influences per accident. And we looked at 27 accidents. And in those 27 accidents, when we looked at the NC Department of Transportation, their accident investigation, they found about 1.5 factors and influences per accident, and they were always focused on the individual person, their behavior, their actions, something about that. And we've certainly found that too, but we tried to look at it a little bit more holistically within the system, and so so we tried to impress upon them that there's other causes of accidents that they should be looking at. Certainly worker actions and behaviors, certainly that was at the top of the list for sure. But there were other things, right? There were worker capabilities, their knowledge, their skill. There were site constraints. There's a lot of site constraints because the DOT is out and about working on roads and in all kinds of different conditions. So there's lots of site constraints things and local hazards. We found a lot of different local hazards that were out there. We did find this thing called safety culture. We actually defined that, for the DOT. We came to an operational definition of that. And so, right, the so what of this particular project was, well, if we can better understand the trends with each injury, perhaps DOT can plan better programs and not just say, well, we're just going to, as soon as someone does something with something, we're gonna get rid of whatever that something is, or we're gonna blame the employee, because there's limits to that. There's limits to the effectiveness of taking that very narrow approach. And so some of the things that we think about, I really like the work of James Reason. I think he has a great quote here. We cannot change the human condition. We can change the condition under which humans work. I think that's a great quote when we think about what causes accidents. And Professor Nancy Levinson up at Massachusetts Institute of Technology, MIT, she does a lot of systems work and human error, and she says human error is a symptom of a system that needs to be redesigned. So we try to take that approach, and this model, I think, helps you take that approach. And so, right, accident causality, it's very complex, very multifaceted. There's almost never a single root cause. Oop, I misspelled that, root cause. Um, and so we all have biases. We have biases, everybody else does, and we want to really look into the system of work. And we think this model helps you do that. So we have this paper that we published from the work with the DOT. And we also did where we worked with Alistair and some folks from RMIT in Australia. They were also using so Helen and Tracy at RMIT, they were using the model at the same time I was using the model, and actually through the group that Prof Lena and I were with last week, we all know each other, and so Alistair said, "Well, Mike, if you're using it, Helen, you're using it. Let's compare." So we were using how we can. This is an article on how we were using this accident causality model. Um, that Alistair was kind of the lead on. So we did this comparison paper. I guess that was a year after I first I published the other paper. So that's another paper I could share with you all. Would be happy to do that. And here's where Lena and I were last week. We were with the group. There's Lena. She's kind of hiding over here, but it was my birthday last week,
Yeah.
and they
Oh, I need this photo. Please share later on, okay?
I think I forwarded this to you right before this presentation. So this is where we were. We were all happy. We were with people from Australia. There's some Australians, some South Africans. Here's a gentleman from Finland, from the UK,
Right. Many of them.
from all over the world. So we were having a great time, and they surprised me with a birthday cake. So I wanted to show that.
Amazing.
So we were working, but we were having some fun as well too. So I'll take any comments or questions from our group, and again I'll share these slides for sure with your profs, and I'll send them the two papers that I referred to as well.
Actually, Prof, yeah, student, please ask a question. And my rules, class rules, right? You have to ask a question before we finish. If you don't ask, we cannot finish the class. And yeah, that's my rules, Prof. So if I have two classes, one classes at least two questions. If not, I won't finish the class. So I must request four questions from them. And yeah, so please ask a question. And actually, we should have more because this one I combine with the undergraduate student as well, and also master student. And undergraduate, some of them have a test today, so they are unable to join all of them. So they have other elective course also, and they will watch via YouTube later on, the or recorded video link, and they have to actually what respond to this talk because they have individual assignment in the for this special lecture. So they have actually 10% of it. If they didn't watch it, and they lose 10% out of total carry marks, for this course. Yeah. So it's very important for them. It's okay. So student, please ask a question. We have master class too. So
Any
yeah,
question?
feel free to ask
Not any question.
anything.
You must have a question.
Yes, and if not, let them hanging here.
We
Let's
have a
open.
lot of folks. So yeah, somebody should.
Or you can chat.
Yeah, Hafiz Chepmat, he one of my master student, I think. Wait, any
Yes,
question?
doctor.
Yeah, please ask a question though. Any
Uh,
else? Wait, who's the
yeah, it's
safety
about
guy?
the
I forgot.
Yes, Hafiz.
Nazi.
Hafiz want to ask a
Please.
question.
it's the in term of education and industry practice angle, doctor.
Yes.
Yeah, are the design professional in the US are better trained to foresee safety risks during the design phase compared to their Malaysia counterparts, in your opinion?
Well, regarding the design, that's a really good question. Unfortunately, here in the US, we do not have regulations that require designers, architects, engineers, or owners of large built environment projects to really do their due diligence. And so, unlike I'm sorry, I'm not familiar with Malaysia regulations as well, but I think I know Singapore has some regulations. Hong,
Correct. Yes.
Hong Kong, does Malaysia have some regulations?
We just started. We just started last year,
Oh,
June
oh,
2024. Yeah, this is what I'm talking with you now. We are on the prevention through design and also
oh,
design for safety. For the US, that I know that they have like a policy on this. It's not like regulation, or you say it's like a best practice. You know, uh, prevention through design from NIOSH. But if I heard from the UK expert and from the US expert, they said they just already become a culture. So that's why they didn't mandatory it, you know. That's why all the even the structure in the US also they already consider
that's
also.
great. We should do some research together
Yeah,
on the
sure.
Malaysia
Yeah,
regulations. Yeah,
sure.
yeah. A lot of my work has been in Singapore, Australia, and,
Yes,
and the UK, because
right, right.
the US really lags behind in terms of design. So, Hafiz, it's a very good question, and yeah, there's pockets of companies that have really embraced prevention through design, but overall, as a country, we really have not. And so, I would say that we lag behind the rest of the world. Certainly, well, in a lot of things, probably, but
Because already developed, you know, those who are developing, they are considering now. Yeah,
that's
right.
great. That's great.
Yeah.
You
And
should.
actually, from the UK, what happened is, last time they make it mandatory, like a regulation under CDM, Construction Design
Hmm.
Management, and then after only a few years, and they stop it, meaning that they remove that what they call law because they already implement it. It become culture, you know. It's
Hmm.
already
Hmm.
being practiced in the industry without that. What they call officer, the professional of designers that they have to see the risk from the design stage. They don't have that kind of personnel. Yeah, so they stop it. Like SHO, light safety and health officer at the construction site, but they have one personnel that have to look after the risk during design. In
Hmm.
Singapore, they have that personnel.
Hmm.
Yeah,
Hmm.
so in
Yeah,
UK, no more.
you should you should have me do a presentation on the work I did in Singapore.
Oh yeah,
I should do that presentation next year
yeah.
for the
Oh,
class.
okay.
Uh,
Good.
yeah, very good question.
Okay.
Thank you.
Yeah.
Okay, thank
And
you, doctor.
yeah. All right. Who's our safety guy in the class? Hafiz, I forgot his name. Nazir.
There's a question in the chat.
Oh, really? Nazli,
Yeah,
where are you, Nazli?
really
Hello.
good question in the chat.
Okay.
How does the Swiss cheese model help us understand the role of design
Okay,
in
good.
construction accidents? Really good question. So yeah, so design would be one of those um, layers of defenses, right? That certainly could be what we would call in this model an originating influence. Um, so if you have poor design and your hole your hole in the Swiss cheese is big, like that first piece of Swiss cheese I showed you that I was holding, if you have poor design, then you would have to have other defenses along the way to help overcome that poor design. So I think if you think about the holes in the Swiss cheese as how poor your defenses are, I think you could say, well, so here in the US, for example, we don't have a law or regulation. So that hole in that piece of Swiss cheese would be pretty big because we don't have good design and we don't think about safety in the design process. So that's how I'd add. That's a really good question. That's a really good way, I think, to think about layers of defenses and how right. So then the question is, how big is the hole in your Swiss cheese in your Swiss cheese? Uh, so you want to have Swiss cheese that has small holes or 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 no holes. You want to reduce the holes in your Swiss cheese.
Right. Any other question, class?
Question.
In Malaysia it's evening, like almost 9 p.m.
I know it's time for
I'm
it's
always behind, so they like I think they are like
I
you know.
know everyone should be tired and ready to re, ready
But
to
you know, my
retire.
class finish until 12 midnight for the master class because they want to start at 8 p.m.
Wow.
So I have to make it until midnight. They are the one who choose it. They couldn't make it at 6 p.m. because it's too big hours to go back
Mm,
home, after
mm,
working. Yeah.
mm.
So after midnight. But yeah, again, class. Yeah, we got a few questions just now, right? I think if we have two classes, we need another two more. I cannot I cannot tolerate with this.
What's about other
Well,
safety?
yeah. Thank you, Noraini, for the questions. Patricia is not here.
Okay.
I think they have a test also.
Okay.
So there's some of them.
What's
Nazli, are you there? We have a not really safety, but quality practitioners. I suppose safety also. Nazli, correct or not?
Yeah,
How
yeah,
to,
Doctor.
please.
Okay,
You
okay.
should
My question is,
more.
in the US, is there any like uh the application of any technology to help in terms of eliminating this hazard at the construction site? Because I also believe that in the US, there's a lot of very high, high-rise buildings.
Yeah,
So the hazard is a lot. So how do you apply technology in the US?
yeah, no, it's a really good question. Some of the bigger companies are trying to use technology. Uh, you know, the use of drones is becoming more popular on construction sites to do things like to inspect things at height. So I do know that the Department of Transportation um, is the Department of Transportation, who we work a lot with here. Um, they're trying to use robots, and there's a robot dog that they're trying to use to pick up litter and trash on the side of the road.
Yeah, I saw it in
Oh,
Purdue too. When I on the way to the our safety symposium, I was just like, what is it just next to me? Yeah, like you say, it's like a dog, but it's a robot.
yeah,
And I was just like, and they just walk around. I was just, what is this? It's not cleaning. Oh, so I just wonder what is it now when you tell that when you tell us that one. Now I know what is the function of that robot
It
because
was
I
picking.
didn't see they pick the trash.
It could have been picking up trash.
Oh
Yeah,
my god, that's so
yeah,
cute. Yeah, I
yeah,
will show it the video later on with my student.
yeah. It's pretty interesting. Yeah,
And
and there's a lot of folks experimenting with exoskeletons. Um, so people are the DOT is experimenting with exoskeletons to try to reduce musculoskeletal injuries and back injuries. With some success.
yeah, I think you missed our safety symposium. You asked me how was it, right? Because you have another session.
Mhm,
And Alicia, I think one of our speaker from industry from Kiwi, Kiwi
mhm,
company, right? So yeah, for everyone information, during that safety symposium, one of the industry practice on looking forwards to already they introduce safety in their equipment. Whatever they're using, for example, machineries, they have like signal. Those who are nearby, I mean, if a worker nearby to their machineries, they have a signal to the driver, something like that. Those the operator, you
mm,
know. So they are safe. And then other things is many of their equipment, the hand tools equipment, they already have extra safety options also. I mean, they are really towards the technology for their equipment and machineries. So yeah, I will share also with my student in the next class if I have what I call opportunity. Yeah, for like they ask, right, how's the in the US, like you said, yeah, they are actually in what I call ongoing. Still actually in practice also. Yeah. Yep.
good.
Anything to add?
Very good question.
Yeah. Mm-mm.
Very good question.
Mm.
Right. Anyone else? One from undergrad student, I think. I believe Noraina is our undergrad student. I want to pick up the name. It is what I have done, If they
Lorena,
don't
I
ask,
have
then I
already
will.
asked the question.
Oh,
Ah,
We have
here's
Amy Noraina. They are
Noraina.
they are
Already
here's
that one.
student. They are
It's a new
taking the
one.
chat box. Okay. Prof,
Amy.
have you encountered any construction projects that managed to successfully apply the concept of prevention through design?
yes. We investigated some unique situations in so for example, one was in Australia where they were building petrol station canopies, and rather than building them at height, they would build them on the ground and use hydraulic jacks and jack them up, and that was a design innovation. um, but then this was like 20 years ago. We were looking at that and working with a company like that. So and in Singapore, we found a lot of innovations as well too, where there were some really unique ideas around the concept, where people were thinking about, well, how are we going to maintain this? And so there were things. We actually wrote a paper called it was around innovations and prevention through design. So that was a really interesting concept. And yeah, there's a lot of examples. There's a lot of examples in the UK. We have some examples here in the US. The Intel Corporation that makes the computer chips, they implemented prevention through design. Oh gosh, this is 25 years ago. And there's been some case studies written on that. So there's a lot of examples and I think once architects and engineers and owners get some ideas, they're pretty creative people. And so we kind of see it kind of we'd call it kind of steamroll. The ideas just start to get generated. So yeah, it's a really good question. And then it looks like there's another question about risk assessments. In the US, again, because there's no law, it's prevention through design is not a widespread thing. And so we're not doing risk assessments in the design and thinking about that. It's really just some of the more leading companies, the larger companies are trying to implement prevention through design, but it's not very widespread.
But yeah, if I can add on, Prof. Mai, actually, US already developed long time ago, right? Like 100 years, more than 100 years ago. What I can see, indirectly, they didn't say in that concept, but actually they practice it already inside. You know what I mean? Because, for example, the
Sometimes.
train, the transportation, they're using steel structure, which is during the operation is much more easier to maintain, but it's a very high, investment from the beginning. Still, it's still structure is a quite, high investment to build. And then the what I've learned from the society too, they said that the demographic, the geographical area, for example, like the coastal, I asked, is there any like a flood nearby, but they said no, there's no they seldom having a flood unless very bad weather, like storm and so on. So meaning they already forecast how much is the elevate they have to elevate, the house and so on. They already forecast for 100 years. So they consider the risk assessment already. Actually,
Right.
indirectly, without a proper concept, but actually they already consider that. That's what
But
I
yeah,
I heard from
they
them.
do, but not for the worker who has to build it, maintain it.
Oh yeah, 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 true. That one is another story. True. For the maintenance stuff, yeah.
Yeah, so
He did put- yeah, understood.
we do that for property.
Yeah, right.
So the question becomes, do we care more about the property or the people building
Yeah,
the pro?
that's why
So
that's
that's
why in the US they're having a problem now, right? During for the maintenance and operation, right? It's not really efficient, is it?
no.
Yeah, not really efficient. Right. True. So they are actually less. Some of it like the some what they call company who practice it, but if the client not look for that kind of company, they won't consider that
Mhm.
risk. Yeah. So we can say yes or no. Because the question, either they implement or not. All right. Okay.
Okay.
All right. So I think it's already now. So Dr. Elma, I think you can hand over this.
End of this. No more question?
Okay,
Good
well,
enough.
it was real
Ah.
nice to spend time with you again.
Yeah. Thank
Thanks
you
for
very
having
much.
me,
Thank you very
and
much.
I'll send you folks an email with the slides and a couple of papers.
Thank you so much,
Right,
Prof,
right.
for your insightful and engaging session. Okay.
Okay.
We want to take a picture. One more again.
Yeah.
Because
Are
let's
we doing one?
Can you put the cover of the slide also? Is it okay? I think because the photo I can see everyone in the on top. The slide, your slide, Prof. Mat.
cover.
I think.
You can share the how to put the cover. So
Oh, the slide with you.
on the slide.
Do you want me to share the slides again?
Can please I mean the front page of the slide so that we can have. Okay, please, we need some of you to turn on the camera so that everyone can. Yeah, that's fine.
The front page.
Let's do that one.
Oh, that's so cute. All right. Everyone,
Alright.
where's the others? Okay, you can
Okay, ready?
screenshot.
Okay, 3, 2, 1, smile.
All right.
All right. Okay.
All
Okay.
right. Thank you.
Hey, thank
All
you,
right.
everyone. Thank
All
you,
right. Thank
Prof.
you.
Bye, everybody. I hope you have a great day and a great class.
See
Yes.
you again.
Bye-bye.
See you again. Bye.
Talk,
Take care.
talk to you soon, Lena. Bye-bye.
Happy
Okay.
belated birthday, Prof.
Yes. Product. Oh, yeah.
Yeah.
Okay, guys. Thank you.
Okay. Bye.
Bye.
Assalamualaikum.